Hey guys, welcome to Unit 6, Section 3, Similar Figures. So we've been talking about similar figures and just that word similar a lot. The definition that we're going to be looking at is figures that have congruent, I'm just going to be lazy and use the symbol, corresponding angles, so the angles are the same, and corresponding sides that are proportional. Meaning that when you're comparing the sides, they reduce down to the same fraction, they have the same ratio. Basically, this is a way to say that it's the same exact shape, that's why the angles are the same, just different sizes. One's going to be bigger, one's going to be smaller. The notation for this, let's say we had two triangles, call them A, B, C. They are similar. Notice how, like, with the congruent sign, we use the little squiggle with the equal sign. Now it's just the little squiggle. Let's say we have a different triangle, D, E, F. That's the notation for this. Now let's look at this with two figures that are similar. So ABCD is a quadrilateral, and it is similar to EFGH. The angle relationships are as follow. We have, let me do a different color here. Angle A is congruent, because the angles are the same, to angle E. Now notice those are in the exact same position, so they're corresponding. Angle B is congruent to angle F. Those are in the same spot, top left corner. They look identical. We got angle C is congruent to angle G. And lastly, we have angle D is congruent to angle H. This would be true for any kind of shape where the angles stay the same. But notice the sides are definitely not the same. It's not the same size. One figure, the first figure, ABCD, is definitely bigger than the second. Now, when I was talking about sides being in proportion, how that looks, let me choose a different color here. Yeah, that's hard to see. Yeah, that one's shows up pretty well. So the side relationships would be like side AB. That is the same, or it's in proportion to side EF, the corresponding side over here. Now, those sides are not congruent. They're definitely different measurements, but they will reduce to the same fraction. So now we do BC is proportional to FG, the top sides. CD is proportional to GH. And then lastly, we have AD is proportional to EH, the bottom pieces. So those should all reduce down to the same fraction if these figures are truly similar. I'll give you a second if you need to pause and write those. Are these triangles similar? Check to see that the sides are proportional. Now we actually have some numbers to test this out. So what we do, assuming that the angles are all the same, because they're marked here, so the corresponding side to 20, the bottom piece, is 12. So we're going to put 20 over 12. That has to be the same. Let me switch colors here again. That has to be the same as 25 over 15. And that has to be the same as 30 over 18. So we reduce these fractions. Remember, to reduce fractions, you just look for common factors. So 4 goes into both of these. We would get 5 over 3. 5 goes into both of these. We would get 5 over 3. And 6 goes into both of these, and we would get 5 over 3. So notice we get the same fraction every time. 5/3 is to 5/3 is to 5/3. So the sides all reduce down to the same fraction. Now, what is the scale factor? This is where it gets tricky. The scale factor can be confusing. So when we are going from the big triangle to the small triangle, RST to XYZ, we are thinking of it as the big number of our fraction, 5/3. But when we are going backwards, when we are going from XYZ to RST, it is actually 3/5. Now, the reason that that seems backwards is because going from the big to the small, 5/3, wouldn't that make it bigger? But it's because we are comparing the big figure first, which is why it goes on the top of the fraction, over the small figure, like that. Vice versa, if we go from the small to the small figure, which is represented by the 3, is on top, divided by the big figure, 5 on the bottom. This is because we have two separate figures, whereas before when we were talking about scale factor with like dilations, the scale factor was referring to an image and then it's like projection, like P and P prime. This time it's two separate figures. I don't want you to stress about this. Just do the best that you can. It takes time and practice, but we'll get it. Okay, last slide here. Are these similar figures? Check to see that the sides are proportional. So again, we do the exact same thing. We find the corresponding sides, we set it up, make sure we get the same fraction. So I'm going to start here. On the very right, for each one, it's 12 and 15. That's got to equal 24/30. And my pen is going to die. And then we got 20/25. Lastly, we have 16/20. Now, for the sake of time, all of these are going to reduce. You can take a 3 out of the first one, you get 4/5. You can take a 6 out of the next one, you get 4/5. You can take a 5 out of the third one, you get 4/5. And a 4 out of the last one gives us 4/5. So when we're talking about the scale factor, remember that if we're going from the small to the big, it's going to be the small number on top, the reduced number divided by 5. And then if we're going from the big to the small, it's just the reciprocal. It's going to be the bigger number divided by the smaller number. Okay? Again, I know that seems weird, but do the best that you can with it. Now go ahead and try the worksheet that is attached to this assignment. If you have any questions, feel free to send me a message. I'll try to respond over the weekend. But if not, we can talk about it on Monday.